Hey guys, welcome back to the DAHKTUBE. And before we get started, don't forget to like, share, comment, and subscribe. So today we'll be doing what is called rationalizing the denominators of surds. So rationalizing surds. So for example, let's say we have monomial denominator. Monomial means 1. So for example, let's say we have 2 over root 3. So in the denominator, we have a surd. So what we'll do is we'll multiply by the surd over the surd. So technically, we're not changing the equation, or we're not changing anything, because if you cancel these, you'd get 1, and 1 multiplied by anything is itself. So now we know that we multiply fractions across numerator by numerator, denominator by denominator. So we have 2 root 3 over root 3 root 3. And if you watch the previous video, root 3 root 3 is the same thing as saying root 3 squared, which is the same thing as saying 3. So that would be 2 root 3 over 3, and that would be a final answer. Another example, let's say we have 1 over root 2. Again, we multiply by root 2 over root 2, and we're multiplying across. So it would be root 2 over 2, because root 2 times root 2, that's 2. So let's try when we have a binomial denominator, meaning we have two things in the denominator. Let's say, for example, we have root 2 plus root 7 over root 2 minus root 7. So what would happen here is that we'd have to multiply by the conjugate of the denominator. Again, if you watch a previous video, you'd know what the conjugate of the denominator would be, which would be root 2 plus root 7 over root 2 plus root 7. And again, we'd multiply across like this. So root 2 times root 2, that will give us 2. So that'll be root 2 squared. And then it'll be root 2 times root 7. And then it'll be root 7 times root 2. So that'll be root 2 root 7. And then this times this. That's another plus root 2 root 7. And then you have root 7 times root 7. That will be plus root 7 squared. Then we do the denominator. So the denominator is conjugate, so we know that the middle terms would cancel. So we'd have root 2 squared minus root 2 root 7 plus root 2 root 7 minus root 7 squared. So this will give us 2. So we'd have 2 plus, so because the orders are the same here, this is technically root 2 times 7, which is root 14. So this and this, root 14. So that means we'll have root 14 plus root 14 plus, this is 7 over, this is 2. These cancel, and this is 7. So we'd have 2 plus, adding these together, we'd have 2 root 14 plus 7 over 2 minus 7, which is minus 5. So we'd have 2 plus 2 root 14 plus 7 over minus 5. So we add in these two. So that will give us 9 plus 2 root 5 root 14 over minus 5. So normally we'd want to get rid of the negative in the denominator, so that means we'd have minus 9 minus 2 root 14 over positive 5. And that would be our answer. Let's try another example. Let's say we have 3 over 4 minus 2 root 5. So again, we'd want to multiply the numerator and the denominator by the conjugate of the denominator. So the conjugate here would be 4 plus 2 root 5. So we'd have 3 times 4 plus 2 root 5. And we'd have 4 minus 2 root 5 times 4 plus 2 root 5. So we can simplify this. So we'd have 3 times 4, that's 12. And then 3 times this one, that's plus 6 root 5. Then we have 4 fours, 16. 4 times this, that would be 8 root 5. Then we'd have this times the 4. So it would be minus 8 root 5. And then this times this. So we can work that out here. So 2 root 5 times 2 root 5. Or 2 root 5 squared. So it will be 2 squared and root 5 squared. Because the power is distributed. So it will be 4 times 5. So that means that would be 20. So that would be minus 20. So I have 12 plus 6 root 5 over, this cancels this. So it will be 16 minus 20. So it will be 12 plus 6 root 5 over minus 4. So we can simplify that and realize that 2 would be common.